In this video here, we're going to be looking at Chapter 4A, problems that you'll see on the quiz. And like all my assessment, they come in 4 levels. And the first level here is always worth 40% of the assessment. So in this case, the first problems are over like complementary, supplementary angles, drawing it in standard position, and also like, can you name the quadrant the angle's in? So let's get started with complementary and supplementary angles. Here I have a question that is helping you define complementary and supplementary angles. So if you remember back in the one of the journals, complementary angles are two positive, make sure that they are positive angles that add up or sum up to be 90 degrees. Now, if you remember, 90 degrees in radians, if you look at a coordinate, you go from 0 to 90 to 180 to 270. We're going by 90s, and then back to 360 is one full circle. Now, if we do it in radians, you might remember that 180 is also equivalent to pi, because the entire unit circle is 2 pi, right? And so if you want to know what 90 degree is, you just take half of pi. So it's pi over 2. So in this case, 90 degrees in radians is also pi over 2. And then supplementary angles are two positive angles, that should be plural, that add up to be 180 degrees, which is equivalent to pi. All right, so let's talk about finding complementary and supplementary angles. So this part, you can use a calculator, might be easiest. So when we're finding complementary angles, if I know that they both sum up to be 90 degrees and I'm already given an angle, that means the other angle is just going to be the difference. So to find the complementary angle, all I have to do is take 90 and subtract it from 51, and that would give me 39 degrees. And then for supplementary angles, I would take 180, because two angles add up to be 180, subtract it from 51, and get 129 degrees. And then this here is my answer. So basically, let's kind of sum up what we did here. So you're given an angle. To find your complementary and supplementary angle, you need to subtract from 90 degrees for complementaries and then find the angle. So notice when you take 51 and add it with 39, those two angles add up to be 90 degrees. Whereas for supplementary, I had to take 180 and subtract it from 51. So then when I get 129, if I add it with 51, I get 180. So that's how you would do it for a degree. Now for a radians angle, you're going to have to use the radians values. So in this case for complementary, you're going to take the 90 degrees, but in this case pi over 2, and subtract it from the angle that you're given, so pi over 4, and treat these as fractions because that's what they are, they're fractions. So you have two fractions that have different denominators, so we have to force them to be the same denominators in order to subtract. So this 2 can be a 4 if I multiply the top and bottom by 2 and 2. So then this here can be 2 pi over 4 minus pi over 4. And notice that this pi here, technically there's a coefficient in front, it's 1. So notice how the bottom here are both 4s, that's good, that means you can subtract. So I'm going to bring over the 4, we don't subtract the denominators, but we do subtract the numerators. So 2 pi minus 1 pi is going to leave you with just 1 pi. Or in other words, you're just left with pi over 4. So my complementary angles, when I take pi over 4 and add it with pi over 4, I get pi over 2. All right, let's find our supplementary angle. So I'm going to do the exact same thing. The only difference is I'm taking pi and I'm subtracting it with pi over 4. So I'm taking that angle they gave me, but I'm subtracting it from pi so I can figure out the missing angle, or the angle that's supplementary. To do this one, I would recommend put pi over 1 so that way it can look like a fraction, because you have to subtract it from a fraction. So we can always take a whole number like pi and put it over 1. From there, you want to make a common denominator. This is a 4. We can change the 1 into a 4 if we multiply the top and bottom by 4. So this is really 4 pi over 4 minus 1 pi over 4. I'm just sticking the 1 there in front of the pi so that way I can easily subtract. You don't have to do this if you can recognize this is 1 pi. 4 pi minus 1 is 3 pi. And then the denominator stays the same. So the supplementary angle to pi over 4 is 3 pi over 4. And then that's it. That is my 2 pairs of complementary and supplementary angle. All right, let's move on to the next thing, which is sketching angle in a standard position. To determine the quadrant, all you need to do is to graph the angle on a coordinate system. So let's practice that. So when you're drawing a coordinate system, remember you have the first quadrant, the second quadrant, the third quadrant. Basically, you're going in a counterclockwise position to name all the quadrants. So 1, 2, 3, 4, counterclockwise. And so what we're going to be doing is labeling this angle here. Now, if you remember, in the first quadrant, this x-axis always starts at the angle 0. Then it's 90 degrees because this here, this perpendicular line is 90 degrees. And then after that, it's 180. And after that, add another 90 degrees is 270. Add another 90, it's 360. So one full circle is 360 degrees. From there, we're going to figure out where this would be located. So you start at 0 degrees, so that's not enough. 90 degrees is not bigger than 120, but 120 is somewhere between 180 and 90. So you always draw your initial angle, which starts at 0, and then you're going to draw your terminal angle, where is the angle that you land at to make the angle that you have, so the 120. And then there we go. Looks like it is in the positive direction because this is a positive 120. So 120 is between 180 and 90, so that means I'm in the second quadrant. So this is in the second quadrant. And that's it. So I have my graph showing it in standard position and also showing the quadrant that it's in. Let's move on to the next problem. So we have a negative angle here. This one's a little bit tricky, but I want you to remember that negative angles go so positive angles go counterclockwise and negative angles go clockwise. Let's write that down actually in problem 9 here. So probably we should have done this problem first. So which directions are positive angles? Well, that is counterclockwise is positive, and clockwise is negative. So if you guys don't know the rotation for clockwise and counterclockwise is the opposite of a clock, and clockwise is the direction how a clock moves. All right, so from here, we have negative 135. And so we, again, start at 0. But if we're going negative, we need to go clockwise, so this direction instead of this way. So to go this direction, this would be 90 degrees, but it's going to be negative 90 degrees. And then we have, if we go to another 90, this would be negative 180 instead because we're going in this direction. But I don't think we need to go that far because this is negative 135. So that means that this here, our initial angle starts right here. Our terminal angle is going to be somewhere in the third quadrant because 1, 135, negative 135, is somewhere between 180 and 90 degrees. So I can't pass 180. I have to be somewhere in this quadrant here. And so this is in the third quadrant. So let's take a look at number 5 next. So number 5, we have 500. And in this case here, it's a positive, so I know that this is going to be going counterclockwise. So let's start by drawing our graph here. So we're going from 0 to 90 to 180, but that's not enough. 270 is not enough. 360 is not enough. So we've already gone over one full circle, and it's not enough. It's only 360. So we have to keep going. And so if I add another 90 to 360, I get 450. But that's not enough. I need to get to 500. So if I add another 90 degrees, this would be 540 degrees. And that's enough. That's way more than needed. So our initial angle starts at 0. And then our terminal angle is going to land somewhere between 540 and 450. So somewhere in here is 500 degrees. But I want you to notice the way we took that. So if you really take a look at how we get to 500, you start at 0 here. You swing all the way around in a full circle to get to 360, but that's not enough. So you go another 90 degrees to get to 450, but that's not enough. So you go another few more degrees until you get to 500. So it looks like from 450 to 500, that's about 50 degrees. So another 50 degrees to get to 500. In the counterclockwise, because this is positive, so we still land in the second quadrant here. So this is still the second quadrant. All right, let's take a look at number 6 here in radians. So for radians, you're going to have to think of it as in the pies. So let's practice that. So we go from 0 to pi over 2, then pi, and then this here is, if I go this direction, I have to add pi over 2 to pi. So that would be 3 pi over 2. Basically, you're taking half of a pi and adding it to 1 pi, so that would be 3 over 2 or 3 pi over 2. And so then if you add another half a pi to this, well, you would get back to 2 pi. Because if you add a half to 3 over 2, you would get 4 over 2, which is 2. So that's why this is 2 pi. From here, let's figure out where to locate 5 pi over 4. So you might have to switch your common denominators to figure this out. So if we look at 5 over 4, right? 5 over 4 is bigger than 1 pi. Like, think about it. This would be equivalent to 5 over 4, if we think about it, is equal to 1 plus 1 over 4, right? If we were to write this as a mixed fraction, let me write that as a mixed fraction. So that means that it already got to 1 pi. So it's past here. So 1/4 is not bigger than 3 pi over 2. And one way I can check this is to change the denominator here. So let's see what this would be with a denominator of 4. So if I make a common denominator, this would be 2 over, this has a 2 in the bottom, so I'm going to multiply the bottom and the top by 2 to make it a 4. So this would be 6 pi over 4, right? So in this case here, let's move this to the side a little bit. I want you to notice that 3 pi over 2 is equivalent to 6 pi over 4. 6 pi over 4 is bigger than 5 pi over 4. So that means that it's somewhere in this quadrant here. So we're going to draw our initial angle. We're going to go all the way around until we get to the third quadrant to have our 5 pi over 4. So it's swinging it this way because it's positive. And how I knew it was between these two is because pi is really equivalent to just 4 pi over 4, right? 4 pi over 4, if you reduce that, that's just 1 pi. So 5 pi has to be between these two axes. So in this case here, we're in the third quadrant. So in the next problem here, for number 7, we have a negative angle. So that means we're going in the clockwise direction. So let's start drawing our coordinate system for a sec. And so we start at 0, but if we're going in the clockwise direction, this is 90 degrees, or in other words, it's half of a pi, or pi over 2. But it's going to be a negative. And so if I were to add another half a pi, I get to negative pi. Now, I don't have to go that far because this is just negative pi over 6, which has to be somewhere between here, because if you notice, this is a half a pi. If you change the denominator by multiplying the top and bottom by 3 to get a common denominator of 6, you will notice that this here is negative 3 pi over 6, which is more negative than this one. So if we draw our initial angle being at 0 and we go in the clockwise direction, we don't have to go very far to have negative pi over 6, because we can't pass negative 3 pi over 6. So in this case, this angle lands in the fourth quadrant. And that's it. All right, moving on to number 8 here. So for number 8, we have 7 pi over 3. It's going to be 0. Let's just write all of this. Actually, before we do, let's see where actually this would land. So this is 7 pi over 3, which is 7. 3 can go into 7 several times. If we write this as a mixed fraction, this would be like 2 1/3, right? 2 1/3 pi. So I just wrote 7 over 3 as a mixed fraction. If this is 2, that means it wrapped around 2 pi. In that case, that means I went all the way around, so pi over 2, pi, 3 pi over 2, another half would be 2 pi. So I already, if I had my initial angle here, I already wrapped around one full revolution, and it wasn't enough. 2 pi is less than 7 pi over 3. So that means, let's take a look. So I've already have 2 pi done. I need about a 1/3 left. So I need to go 1/3 more. 1/3 pi is not bigger than half a pi, right? Because half a pi is really, if I wrote that with the same denominator, or, yeah, I'll just write the same denominator. If I think of this in terms of 6, I can write 1/3. If I multiply it by 2 in the bottom, this would be 2 over 6. So that would be how it looked like if the denominator was 6. Whereas pi over 2, if I wrote it in the same denominator as 6, I would multiply the top and bottom by 3 and get 3 pi over 6. So notice that 2 is less than 3 pi over 6. So it's somewhere in the first quadrant is 7 pi over 3. So here's what happened. You went around one full circle, but it wasn't enough because it only got you to 2 pi. Or in other words, 2 pi is also equivalent to 6 pi over 3, right? And that wasn't enough. You needed to go a third more. So we went a third more and landed in the first quadrant. And that's it. All right. That was a lot of information there. So we've already done number 9. Let's take a look at level 2. Sorry, I'm trying to get this out of the way. There we go. Okay, so when it comes to converting from radians to degrees, what you need to do is remember that if you're given the radians already, so let's say you're given, I'll just write radians, you need to multiply by a ratio of pi in the bottom and 180 on the top. So we might remember that 180 degrees is equivalent to pi, right? These are equivalent to each other. This is in degree form, this is in radians form. But you want the radians to be in the bottom, or the pi to be in the bottom, so they can diagonally cancel out the unit. If they're the same unit and they're diagonal from each other, they will cancel out the units. And that's why you'll be only left with degrees. Whereas if you had degrees, you want the 180 to be in the bottom and the pi to be on top. And that's how you can convert. And so we're going to practice this skill. So when we are converting, so we have to convert and sketch the graph. Let's first convert these radians here. So if I have radians, I notice that this is radians because it has a pi. I need to multiply by the pi being on the bottom and 180 on top. Okay, so I'm always multiplying by this ratio of 180 to pi. And the pi's are going to cancel because they're diagonal from each other. And let's see what else we can reduce here or cancel. So 3 and 180 both can be reduced by 3 or divided by 3. 3 divides into 3 one time. 3 divides into 180 60 times. And so if I multiply straight across, I have 8 times 60, which is 480. And then just 1 left in the bottom because the pi and the 3 cancel. So 480 over 1 is just 480 degrees. And that's it. So that there is my angle. And I need to draw that angle. So it says sketch the angle. So if I draw a coordinate system, let's see where this would land. We'd have 0, pi over 2. Oh, let's not go by pi over 2. This is in degrees. So this would be 90, 180, 270. I'm going by 90s. 360. But 360 is not enough. 480, let's see where that would be. If I add another 90 degrees, that would be 450. If I add another 90 degrees, that would be 540. So it's in between somewhere in the second quadrant, because 450 and 540, 480 is between those two numbers. So we're going to have our initial angle at 0, and it went all the way around to 360, but that wasn't enough, so we had to get to 480 by going all the way over just a little bit more in the second quadrant, drawing our angle, 480 degrees. And so we're in the second quadrant, but it doesn't ask to write the quadrant, so you don't have to. I think you just have to sketch the graph, that's all. All right, let's take a look at this next one here. So again, this one is also in radians. So you want to do the one that is pi in the denominator, or multiply with pi in the denominator and 180 on top. So again, the pi's will cancel because they're diagonal. Let's see what else we can try to reduce. Now 4 can go into 180. So 4 goes into 4 one time, 4 goes into 180 45 times. If you take 180 divided by 4, it's 45. And then this diagonal, I can't cancel out anything, so I'll just leave it as it is. And so from here, I need to multiply. So I'm taking -5 times 450. So that's going to give me -225. And then the bottom, notice that the bottoms all cancel. I'm just left with a 1 here. So I just have 1 in the bottom. So this is -225 degrees. Since I've already canceled out the pi's, all I'm left with is the degree. And so that there is my angle. Let's draw the graph. So if I were to sketch the graph here, I'm going in the clockwise direction because I have a negative angle. So this is -90, -180, but that's not enough. -270. And that seems to be enough here. So -225 is somewhere between 270 and -180. So I started in the initial angle at 0, went all the way around in this direction, and landed in the second quadrant for -225 degrees. So this is also in the second quadrant. Would you look at that? All right, let's move on to the degrees and how to convert those to radians. So to do that, we need to take our ratio, but now put the degrees on bottom. So 180 is now on bottom, pi is on top, so that the degrees will cancel. So technically there's like a degree side here on the 180 and they would cancel. Now you don't have to physically do that, so that's kind of redundant. So from here, we're going to need to see if we can cancel or reduce any numbers. So I can put this over 1 to make it a little bit easier to try to think of numbers to reduce. So these numbers are diagonal from each other. So 225 and 180 are both divisible by 5. So let's take a look. 225 divided by 5 is going to be 45. And then 180 divided by 5 is going to be 36. So in that case, let's move this over. We have a 45 here multiplied by pi. So 45 pi over, my denominator is just a 1 times 36 that I've reduced. But this here is still reducible. Like 45 and 36 are both divisible by 9. So that means that this would be 45 divided by 9 is 5. 36 divided by 9 is 4. So technically, we can say that this is 5 pi over 4. I can't reduce that any further. So this here is my angle that I'm working with. And if I were to write that in a coordinate system in radians, this would be 0 to pi over 2 to pi. I think that's enough. Maybe not. We'll see. So this is 5 pi over 4. If I think about pi, I can always write that in a denominator of 4 if I do 4 over 4, right? 4 over 4 is just 1, so that would be 1 pi. But that's not enough. I want 5 pi. So I probably got to go another half a pi. So that would end up getting me to 3 pi over 2. Or if I want to make it the same denominator, I'd multiply the top and bottom by 2. And this would make it 6 pi over 4. And that's plenty. So that means that 5 pi over 4 is somewhere between these. So I'd start my initial angle at 0, like always, go all the way around, and then land somewhere in the third quadrant at 5 pi over 4. So this is the third quadrant. Okay. Now this problem here is a negative angles, but again, this is a degree, so we need to multiply by 180 in the bottom and pi on the top. So again, we're going to see what numbers go into 120 and 180. I think they're both divisible by 60 degrees. So 60 goes into 120 2 times, and 60 goes into 180 3 times. And you could put this over a 1 if that makes you more comfortable with dealing with fractions. But if you multiply straight across, negative 2 pi would be the top. And then the bottom here is 1 times 3, which is just 3. So this is negative 2 pi over 3 as my coordinate. Or not my coordinate, but my angle. And so if I were to draw this, this would be at 0, but it's a negative, so I need to go in this direction. So it'd be negative pi over 3. Sorry, negative pi over 2. And then this would be negative pi. Okay, so from there, we need to figure out where this guy's located. I can keep going around, but I don't think I need to. So if I were to convert this to a denominator that is equivalent to 3, 3's are tricky because in order to make them both same denominators, I need to change them to a 6. So let's go ahead and do that. If I were to change this denominator to 6, I would multiply the top and bottom by 2. This would give me negative 4 pi over 6. If I multiply the top and bottom by 2, I get negative 4 pi over 6. This guy here is equivalent to negative 3 pi over 6 because it's half. So another way to write half is 3 over 6. And notice that this is not enough. This is a 3 and this is a 4, so I need to keep going. And then this here is negative 1 pi, which is also equivalent to negative 6 pi over 6 because this is technically a 1 in front. So 6 over 6 is equivalent to 1. So that means I can't go further than negative pi, but so it's somewhere between this axis and this one. So I draw my initial angle, draw my terminal side. So I went all the way in the third quadrant to land at negative 4 pi over 6. All right, and then we are done there. So in the next video, we'll talk about coterminal angles, but I think I want to end the video here.